I'll have a pen if that's okay. Do you need it? Okay. I have one pencil with an eraser. See if I can do that instead. So we have Dylan that borrowed, Zach, Luke. Did anybody else borrow anything? Alright. Do you have a question or anything? Yes, which question?
Are we going to finish our birthday?
No, we probably will not finish those until tomorrow. We're going to cut the next one today. Yes, we're getting in our groups. Not today.
Are we doing that long?
Not today. We'll go around. Yes.
Are we going to finish up the lockdown hour?
We are not today. Yes. I have pens. I don't have a pen to sharpen. What? Yes. Okay. Yeah. Karen, Mr. Long, you come back for just a second. Oh, yes. Just a second, yes. Is everybody written down the bell ringer? It needs to be out still. Okay. It'll do. All right. We got a couple people still working on them. That's fine. Yes. It doesn't work. That's where it was supposed to start. Start putting here. Okay. Yes, and then you're going to staple them in the back of your.
I didn't know that.
Yeah.
I was just giving them.
No, yeah, just go ahead and staple them in the back of your. I don't have a stapler, so you'd have to staple in the class, but. All right. So, our bell ringer, before we get to it today, there are 10 people in this classroom that I did not receive a final writing piece from. It's final draft writing piece. Listen. Okay? Okay? Now, it needs to be in my hand before we leave school tomorrow, or else you will be staying after for detention and finish it then. Okay? Now, I'm not going to read the list out loud. You can check the list before you leave class today, but you will not be getting up in the middle of class. You will wait until after class when I dismiss you to check it. Okay? All right. Now, on to the bell ringer. What is gravity? What is gravity? Alan, what's gravity?
The force that brings stuff down.
Okay, the force that brings stuff down. Did anybody have anything different? Sierra, what'd you have? Okay, when mass changes on objects, you're close, but you kind of got something a little confused, but we'll learn about it in a little bit. Will,
redo the drawing because I couldn't see it. I thought it said your feet.
No, gravity, that's okay. You can just kind of go along as we're doing it right now, okay? Dylan, what'd you put?
An unbalanced force that keeps things from leaving the ground.
Okay, an unbalanced or a balanced force that keeps things from leaving the ground. What'd you say?
Unbalanced.
But am I keep going down? Am I being pulled all the way down into the
I
ground?
hope it doesn't.
Because there's a balanced force that's pulling the other way on it, right? So it is a balanced force that keeps us on Earth. Brittany,
I said a force that acts upon something.
a force that acts upon something that is a force. Emily,
A push or pull against an object.
a push or pull against an object. Okay, good. Well, in this case, it would be a pull, right? It would be a pull against an object. Gabe,
I put that it's an unbalanced force that pulls objects toward you.
okay. In some cases, it would be unbalanced. I understand where you guys say that, but you're standing on Earth, me standing right here. I'm not pile driving into the ground, so it would be balanced because there's a balanced force that's pulling the other way on me, right? Unbalanced would be like somewhere where you're like you try to jump and you float because there's less gravity. Okay, good. What in the world are we talking about gravity for? We'll find out what gravity has to do with what we're talking about. But today, before you leave, you will be able to compare the concepts of mass and weight for me. You will be able to compare the concepts of mass and weight. All right? They are two things that are very important to what we've been talking about, but we are taking a step back from what we've been doing to kind of look at these two things. All right. What we're going to do today is we're going to investigate, are mass and weight the same thing or are they different? The first thing I want you to do right now is I would like for you to pull out a separate sheet of paper and I want you to put your name on it. Everything we do today is going to go on this separate sheet of paper. You're going to do your name in. You can do it on this one. Yes, that's fine. Yes, that's fine. On a separate sheet of paper because we're going to be turning in what we do. The very first thing I want you to do is to pull it out and put your name on it. Pull out a piece of paper, put your name on it. Everything you do today will be on this piece of paper. This piece of paper is very important and very vital to you. Okay? Good. Good. All right. Is there anybody that needs a piece of paper? We good? Okay. All right. I don't know what you guys are passing back and forth, but it needs to stop. All right. On this piece of paper, what I want you to do for right now, I want you to take a look at this picture, and I'm going to give you about 5 to 7 minutes. This picture is representative of the comparison of mass and weight. What I want you to do in the next 5 to 7 minutes on your own, so that means there is no talking, all right, because this is an individual part, all right? You are going to tell me you're going to give me 2 observations from this picture. 2 observations. Now, an observation, somebody tell me what an observation is. Somebody tell me what an observation is. Logan.
To look.
Okay, it's something that you can look and see in this picture. It's something you can physically see in this picture. 2 observations. I want you to pay attention to detail when you're looking at it. I want you to pay attention to detail. All right? Now, I also want you to write down 2 inferences. Can anybody tell me what an inference is? 2 inferences. These are what you're going to put on your paper, okay? What are inferences, Shelby?
What you think?
Okay, something that you can conclude, something you think from looking at this picture. Yes? An educated guess and a hypothesis that you pull from this picture, okay? Give me 2 inferences that you can pull from this picture. I will turn the lights off. You're going to write these both on your paper.
One thing on there.
The whole picture.
Well,
Okay.
it's gonna take me a while, so I'm
That's fine. That's why I'm giving you quite a few minutes.
Guess that.
I'm going to give you a couple minutes. Give you about 5 to 7. But,
I already know what is the
So,
listen very carefully. Very carefully. You're going to give me 2 observations. 2 things that you physically can see. 2 things that you notice about this picture. Okay? Then you're going to give me 2 inferences. An inference is something that you conclude from this picture. Something you conclude from this picture. Now, these are representative of mass and weight. This is a picture, a diagram representing mass versus weight. Okay? So, That means that you are making two inferences about mass and weight from this picture.
So
Two
which one's
conclusions.
mass and which one's weight?
I want you to decide.
So are these, like, is this picture different, this picture is different? Like,
Right, each column is representing something different. Good. That's up to you. This is completely on your observation and your inference. This is coming from you. Everybody's eyes should be on that screen, unless you're writing on the screen or on your paper. Yes, we're turning this paper in before you leave this classroom today.
Answers, but
That's okay.
that matters.
Right now, your observations and your inferences are all your own. This is what you observe and what you inference from it. Try, just do your best, okay? What? Well, your observation should be something that you see. So these pictures are all representative of something. See if you can try and figure out what they're representative of. This is a good one to, when you're doing your inferences, I want you to infer which column is representative of weight and which column is representative of mass.
What is that orange one?
It's a planet. Let me see if I can zoom in on it just a little bit. Pay close attention to detail. I will say that. Pay close attention to detail. These right here, these weights right here, they say 1 kilogram, by the way. I know they're hard to read. Pay close attention to the scales and the dials. Right there. From what you can see from
The
this.
dial is like the little thing that points to.
Yeah, it's it's like it would spin around. I don't know if you call it dial, what you would call it, but whatever the what you would call it. Pointy thing. What position they're in, the pointy thing, whatever position the pointy thing is in. All right. If you have both of your observations and both your inferences, please put your pencil down so I know you're finished.
How move up?
Position, is that what you're asking?
Tom, I'll move up, I can't see.
Temporarily, yes. You can
What's
come where
the
this chair is right
thing
here.
we do?
I'm gonna ask Madeline. He's gonna move up so he can see. Two observations and two inferences.
Okay, so what would you call that little thing that, like a dial?
Yeah, a dial. It's the same thing as if you looked at this. You see how there's a little arrow that points to what the weight is? That's what that is. That's what that's supposed to be. And like I said, if you finish and you kind of look at it and you see something else, go ahead and write it down.
What is that? Is that like a little bottle of liquid or something?
This section.
What'd you say? Sorry.
Is that a little bottle of liquid?
No, it's a weight. It says 1 kilogram. But just whatever, do you have one of these?
I have a column one, but I have one observation, I don't have any answer.
You only have to have 2 observations total and 2 inferences total.
No.
Not about each column.
All in both columns?
Yeah, about both. I was just posing the question that if you were talking about inferences, one of these columns is representative of weight and one of them is representative of mass. So one of your inferences could be guessing.
That one column make 4 and then the other column.
Oh, no. Like, you're guessing, if you're having to guess anything. Okay? All right? All right?
What's the inference?
Inference is something you can assume from looking at this picture. We still got people making inferences and observations. That's okay. We're going to go ahead and start. Keep writing down your inferences and observations. All right. So, all right. So anyway, 2 observations. Who wants to raise your hand and tell me 2 things you observed about this picture? What are 2 things you observed about this picture? Emily, what are 2 things you observed?
Like 2 things that I wrote down.
Yes. You 2 of your observations, just observations right now.
Okay.
Or 1, whatever.
On the weight scale, there's like, they have different scales, but on the weight, the dials are all in different positions.
Okay, so she observed, so this is an observation because she saw this. She observed that on each scale, the dial is in a different location. Okay? The dial is in a different location. Good. She observed that. Logan.
On the one on the up there, on no matter what planet, but it's 21 kilograms.
Okay, so he observed that no matter what planet they're on, that the bananas in the kilogram are balanced, right? They're the same. It's the same on any of those planets. Okay? What other observations did you guys make? Well,
The banana on the left side's upside down.
so this bottom banana is upside down. Good. I was waiting for somebody to observe that. The bananas on the left side are upside down.
Teachers, excuse this interruption, but at this time, all those students who are on the field trip with Mr. Flynn to West Irving need to report to lunch. And all those students on the field trip with Mr. Flynn need to go to lunch at 5. Your teachers will go there with
Okay. So, what other observations did we make? Jesse?
Observation that scale was on the earth.
That what?
The scale was on the earth.
Okay, the scale is on the Earth. Okay, so he's observing that planet Earth is on there. Good. Dylan.
One of the bananas have not as many bananas as the other one. It looks like.
He says, okay, it looks like there's not as many bananas. Oh, you're leaving too. I'm sorry. Let me have your all sheets that you were writing on. Just put them in the 4Q tray. All right. Okay, so he's observing that. What did you say again?
Like this banana
Okay.
doesn't. It looks like it doesn't have as much as like that one.
Okay, he's saying he's observing that it doesn't look like there's as many bananas. Okay. Yes, Alan.
On the left side,
Okay, so he's observing that the scale is different than the one on the left and the one on the right. It's because they are completely different instruments. Good. That's a very good observation. That's not one I've heard today yet. Sierra.
I seen white on page something and then something blue, something up.
Okay, so she's also noticing the scales, the 2 different types of measurement that you can use. Juliet.
Cause he's playing.
Okay, there's different planets. Good. Dylan, last one.
That left scale, I think is like measuring mass.
Now that's an inference,
I'm
not an observation. We're on observation still. Okay? Did you have one more observation?
like at the top, the red one kind of makes the planet look smaller than the black one does.
Okay. Okay, good. All right, so we've got lots of observations, and you guys observed a lot of really good things. And a lot of those things you can use to make an inference. So now, what are some inferences you made from what you observed? What are some things that you concluded from what you observed? Jesse, what did you conclude?
Balanced and unbalanced forces are used.
Okay, balanced and unbalanced forces are used. He concluded that. Are you saying it's balanced and unbalanced because like the scales are kind of unbalanced, but the other one is not? It's balanced. Okay, I can see where you could conclude that. Brianna.
I said that the banana, like on the bottom that's turned upside down, would have a different weight because it's upside down.
Okay, so this banana on the bottom would have a different weight because it's upside down. That's what she inferred. Dylan.
They're all measuring things.
Okay, they're all measuring something. That's a good inference. Good. Sierra.
It looks like this side is telling the weight and this side is telling the mass.
Wonderful. Wonderful. Sierra said that this side right here is representative of weight. And this side right here is representative of mass. So, based on this, what can you tell me about weight and mass? How are they different? How are they different? Alan.
You can have like a planet that's all about the whole the same. it won't be the same weight as a plane.
Okay,
They'll be
So,
beautiful, beautiful. He said this one was weight and this one was mass. Okay, he said that you were gonna weigh different things on different planets. Okay, he essentially said that your weight would be different on a different planet. Why is that? Why is that? Why is your weight different on a different planet? Oh, Aiden, I know you have it. You forgot? Who knows? Somebody I haven't called on yet today. Zach.
because gravity changes.
Okay, there's different, gravity exerts a different force on different planets. So, would I be fair enough on saying weight depends on what? Weight is dependent on what? Gravity. Good. Weight is dependent on gravity.
is that like a,
Yes, that would be a good inference that we made together, is that weight is dependent on gravity. Okay. What else? What are some other inferences you made? Brody.
Like, this isn't about it, but like,
Girls.
for the ones we just did, it's kind of like if you go to space, like, how you could lift like 500 pounds there, you could lift in space when you do it.
Because there is no what?
Like,
It's because of gravity. There's zero what?
Air.
Not mass.
of course.
There's zero gravity, so there's zero what? If weight, good. There's zero weight because there's zero gravity. Good. Okay, so that leaves me, why are these bottom bananas flipped upside down? Somebody tell me, why are these bottom bananas flipped upside down?
There's
What does it
only one
represent?
that's
Raise your
flipped
hand. Raise your hand.
There's only one that's flipped upside down.
I said the bottom bananas right here are flipped upside down. Why are they flipped upside down? Why? What is that representing? What is that representing? What do you think? Jesse? Okay. It's representing that there's what kind of gravity? How much?
Zero.
Zero gravity. It's representing weightlessness with zero gravity. Because you notice it's not on top of any planets or anything, right? So none of that means that there is zero gravity. Good. You guys are making some excellent inferences. Okay. What other inferences did we make? Luke, did you make any good inferences? Or the same that everybody else has? Sierra.
on mass, depends on something and weight accelerates.
What is it? Sorry.
Weight accelerates and mass depends on something.
Okay, so she's saying that weight accelerates, and she's correct because gravity is making it accelerate. That is correct because gravity is making it accelerate. Good. All right, so we're gonna move on. You guys did some awesome inferences about mass and weight. Now we're gonna learn a little bit more about it. Okay? They were flipped upside down because it was representing weightlessness or zero gravity. Here's what we're going to do. Raise your hand if you have never done a Venn diagram. Raise your hand if you've never done a Venn diagram. Two circles that intersect. Okay. All right, we're going to be watching this video from NASA about the difference between mass and weight. Yes, Brittany?
When you get a chance, come here. I need you for a second.
All right, so we're going to watch this video about the differences between mass and weight. What you're going to do on that paper is I want you, that you put your observations and inferences. I want you to draw a Venn diagram.
Can I do the back?
Yes, you can do it on back. All right? You're allowed to do it on back.
Is it like
Big, so you can write it. Big.
The whole back.
It can, but you'll need to, yeah. You can. You're supposed to do it on that same paper. Okay?
Like this one.
Thompson?
Fine. Yes. Yes.
Is that big enough?
It's gonna depend. It depends on the force of gravity, really. They'll actually show you in this video. Yes, Jesse.
What do we like about weight and then gravity or gravity?
You're gonna do mass and weight.
Mass and weight?
Mass and weight. All right. As the video plays, you are gonna write down anything you learn about mass and weight. Now, if you are not familiar with how a Venn diagram works, okay, on this side, you are gonna write down anything that is unique characteristic to mass. Anything that is a unique characteristic to mass. On this side, you will be writing any unique characteristics about weight that you learned. In the middle, you're going to write things that they have in common. Okay? You are going to write things that they have in common.
How are you supposed to write mostly at the same time?
Oh, it's pretty easy. They talk really slow and they have captions. So, I'm gonna go ahead and play this video for you. It's actually really neat. This is some of the NASA astronauts up in the space station actually making this video. So this is really cool.
Hi everyone, my name is Nicole Stott and I'm a flight engineer with Expedition 20 on the International Space Station. And we're here today with you on the International Space Station and the Japanese Laboratory Module.
Hi, I'm Bob Thirsk. I'm also a flight engineer aboard Expedition 20. The topic for today is weight versus mass, a heavy-duty concept.
So what is weight? Weight is the vertical force exerted by a mass as a result of gravity. Weight also means the strength of the gravitational pull on the object. That is, how heavy is it? Weight is dependent on gravity.
On Earth, in a 1G environment, an astronaut in his spacesuit would weigh 360 pounds. On the Moon, in 1/6 Earth's gravity, the astronaut would weigh 60 pounds. In orbit, he would weigh 0 pounds because weight is dependent on gravity and the effect of Earth's gravity is not observed.
Using more physics and mathematical terms, weight is defined as the force with which a body is attracted to Earth or another celestial body, equal to the product of the object's mass and the acceleration of gravity.
Okay, that's really
So
big.
in
You don't
equation
have to write all
form,
that down.
gravity equals mass times acceleration due to gravity. On Earth, that's 9.8 meters per second squared.
So what is mass? Mass is the property of a body that causes it to have weight in a gravitational field. The mass of an object is not dependent on gravity. Mass is the amount of matter in an object. Bodies with greater mass are accelerated less by the same force.
If we use the same force on these two animals, the elephant, which has a greater mass, is affected less than the mouse, which has much less mass.
What's the
And what
I
is
word
gravity?
that we describe that?
Gravity is a force that governs motion throughout the universe. It holds us to the ground. It keeps the moon and the station in orbit around the Earth, and the Earth in orbit around the sun. It is best described as the attraction between any two masses, most apparent when one mass is very large, like the Earth. The acceleration of an object toward the ground caused by gravity alone near the surface of the Earth is called normal gravity, or 1G. This acceleration is equal to 9.8 meters per second squared, or 32.2 feet per second squared. If you drop an apple on Earth, it falls at 1G. If an astronaut on the space station drops an apple, it falls too. It just doesn't look like it's falling. That's because they're all falling together. The apple, or the onion, the astronaut, and the space station, all falling together.
Well, what is microgravity? The International Space Station and us astronauts aboard are traveling at approximately 28,000 kilometers per hour, or 17,500 miles per hour. And we're essentially falling around the Earth, creating weightlessness. The weightlessness that is felt in free fall on a ride at an amusement park or on the International Space Station when it circles around the Earth is microgravity. Objects in a state of free fall in orbit are said to be weightless. The object's mass is the same, but their weight would register 0 on a scale. Weight varies depending on if you're on Earth, the Moon, or in orbit, but your mass always stays the same.
That seems like a pretty important point.
First thing that Koichi and I would like to do is demonstrate that we're actually on board the International Space Station and we're in a weightless environment. So let us show you a few little tricks here that will make that point.
Hello. Thank you.
Oh my God.
Guess what? We'll get to see more of their antics. All right, please show me what you need to do to be. Please show me what you need to do to be
Someone's
done.
holding the stage flag.
That's weird. Show me what you need to do. I got it right. Go on. Go get mine.
It looks cool.